It is Monday, November 1st. Just put in your expandable. We have one more lesson after today, and then we have our test on Friday. So if you're watching this recording, you should have received your Unit 2 study guide today. I think I'm going to post a copy of those in your Google Classroom as well, so that you have it there as well in case you lose it or you want to do more or something. I don't know. I'll post it in your Google Classroom as well. Before we get started, I want to review the 3 things we know about comparing fractions, because today I'm going to add a 4th. We know 3 ways to compare fractions. What are they? Trenton?
Comparing the whole.
Compare to the whole. Jackson?
Compare to the half.
Compare to the half. Izzy?
Compare to the denominator.
Use common denominators. Those are the 3 ways. When we compare to the half, or to the whole, I mean, we're looking at what does it take to make a whole. So if we have 6/3 and 12/4, how many wholes is 6/3? In order to know that, we have to know how many it takes to make 1 whole. So if I have thirds, how many pieces do I need to make a whole, Cameron? I need 3 pieces, but I have 6. So how many whole pieces do I have here? Cameron, this is yours. How many whole pieces do I have? 1 whole. 1, 2, 3. 1 whole. 4, 5, 6. 2 whole things, right? So 6/3 is the same as 2 whole things. What about 12/4? 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11, 12. How many holes do I have, Emma? I have 3. So that tells me that 12/4 is larger than 6/3. That's how you compare to the whole. If your eyes are on me, then I'm confident that you're listening. So I'd appreciate your listening selves. You compare to the whole by seeing how many are in the whole. Here is 3, here is 4. And when I have 6/3, I have 2 whole pieces. Or if I have 12/4, here's 1 whole, 2 holes. 12/4 is 3 holes. That's how you compare to the whole. Okay? Now, how do I compare to the half? What am I going to do to compare these same things? Oh, it's not the same things. I just flipped those numbers. That made my brain do mind tricks for a second. Emma, talk to me about comparing to the half. I was like, why did I not have trouble with this and any of the other things?
So like 3, 6, 3 is half of 6. So that's half. Then 4 is 12. 6 is half of 12. So it would be 3, 6 is more than, so it's equal to 1/2. And then that's 5.
So she's saying 3 6 is equal to the half because 2 3s make a 6, right? And 4 12s is less than the half. So we can say that 3 6 is bigger because we're comparing it to the half. This is all review. We've already done all this. So this is just a quick review of what we've already done. Because the way that we teach and the way that you learn is by adding on to the things you already know. So I'm trying to remind you, hey, remember, you already know this. You already know this. You already know this. We're going to add on to that today. Please stop. We're going to add on to that today. Now, we can use common denominators. And we can use multiplication or division. And so I tried to type this on here, but it's really hard to tell with the typing like that. So we're going to do the 4/12 and the 3 6 again. We already know the answer, right? But I like to use ones that we already know the answer to so that you can follow along better. When I say a common denominator? What does that even mean? Because in order for us to have success in today's lesson, we really need to know what that means. What is a common denominator? Where both of the denominators are the same. Good job, Cameron. Whenever I ask for something common in a math class, that means I want to match. I want them to be matching. And so I want a matching denominator. What am I going to do over here to get a matching denominator? What am I going to do here to get a matching denominator, Bobby?
You times it by 2.
Times what by 2?
The 6 and the 8.
Good job. I'm going to times the 6 by 3, and that's going to get me 12. Why do I have to do the 3? Oh, yes. 6 times the 6 by 2, and that's going to get me the 12. Why do I have to do the 3 times the 2 also, Bobby?
Because when we get to the bottom, we must do the top.
And why is that?
Because it won't be then you won't get the actual answer.
That's right. And what does this mean? What does this mean?
It's common denominator.
Sort of. Cole, what's this mean? This means one whole thing. And anything times 1 is itself. So we're not changing the size. We're just giving this fraction a new name. Good job. 3 times 2 is 6. So now I can look at this fraction and this fraction. And since 3/6 and 6/12 are the same, please don't do that, are the same, then I can see that the 4 is less than the 6. And so my alligator wants to eat the bigger number, right? Mm-hmm. And so that would go like that. See, I tried to do that here. Yeah. It just
kind of worked.
Yeah, sort of, not really. Notice here, I have this big yellow blank spot. That's because in our strategies for comparing fractions, we are going to add something in this area. We're going to add to the common denominator story. That's what we're doing here today. So let's get started. Here we go. Here's what I found. Oh, thank you, Siri, for saying everything I said in the last 5 minutes. Common denominators to compare. Let's compare fractions by writing equivalent fractions with the same denominator, shall we?
Yes, we shall.
Oh, you're tired on this Monday, aren't you?
Yes.
You sleepy, tired little 4th graders.
Yesterday
Oh, it's so tiring, I know.
My eye, under my eyes, I saw too much candy.
So look here. What fraction am I going to rewrite, Annabelle?
3 and 5.
Very good. I'm going to rewrite 3/5, and what am I going to turn it into?
So 15 by 5 times 3.
Beautiful.
3 times 3 equals 9.
Excellent. So what does that tell us?
That
No, go ahead.
3/5 is bigger than 2/15.
Excellent. Raise your hand if you understood what Annabelle just did. Hands all over town. If you understood what Annabelle just did, you are in beautiful shape for today's lesson. This is going to be glorious if you understood that. So, what do you know about 15 and 30? 15 and 30. Give me something, Jackson.
That 15 times 2 equals 30.
15 times 2 equals 30. What do you know? Izzy.
15 is half of 30.
So
Like a different way Jackson read it.
So you want to do
15 and then
15 30ths equals 1/2?
Yeah.
Whoopsie.
That one went.
1/2?
Yeah.
Okay. Sure. Remington.
1 times 15 is 15 and 1 times 30 is 30.
Okay.
Basic.
Yep. Emma.
15 and 30 is 5.
15 and 30 are both multiples of 5. 5, 10, 15, 20, 25, 30. Interesting. How do I get here? It's 5 times 3, and here it's 5 times 6. Okay, interesting. Cameron? 30 divided by 2. Oopsie. Sorry.
Keep writing
You just love ones today.
I know. I got 15 on the brain. I keep trying to write a 15. Are all these things true?
Yes.
Yeah.
Very nice. Oh, one more, Annabelle?
That 15 and 30 also 15 and 30 are also multiples of 3.
Prove it.
3, 6.
Dun, 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 dun. 3, 6.
9, 12, 15, 18, 19, 18, 21, 24, 27,
I'm running out of room.
30.
We have a 15 and a 30, both in the multiples list of 3. So what we're learning is that 15 and 3 have a relationship with each other, but 15 and 3 also have a relationship with what two numbers? Jackson?
3 and 5.
3 and 5. They are really good friends with 3 and 5 too. Right?
Mm-hmm.
Yes?
And then also, I noticed that for the 15, for the 30, the tens place is 3, and for 15, like the 5. No, never mind. I'm being wrong. Never mind.
Are you allowed to make mistakes in math?
Yes.
Does that make me upset?
No.
No, that makes me happy. Why does it make me happy? Because that means we are
Learning.
Yes, thank you. Hey, these are some excellent things. This piece here, this piece, all of it, this piece here, all these things, this here, this is like, all these things are excellent thoughts. If I were to ask you, what are the factors of 15? What little song would you sing to remind yourself of life, Chloe? Okay, Anna? So if I'm going to write a factor rainbow of 15, what's it going to start with? Anyone? 1. What's it going to end with? 15. Itself, yeah, which is 15. And what is next?
2, but it doesn't.
2's not it, right? 2's a miss. 3 and 5. Is there anything else? I'm not very artistic, but my artistic self just needs there to be an actual rainbow, okay? I'm sorry. This is the rainbow for 15. Good job. Well, how are we going to start our rainbow for 30? We're going to start with 1 and end with 30. There you go. 1 and 30. What comes next?
3.
What comes next? Cameron? 2 and 15. 2 and 15.
3 and 5.
Good, Remington. Wait. Not 3 and 5. 3 and
10.
3 and 10. 3 and 10. You can. How many 5s do you need to get to 30?
5, 10, 15, 20. Oh no, I can do 3. 5, 10, 15, 6.
So, 5 and 6. Is that it? So, now, what factors do Hey, Bobby, you're out of here. Get out of here. Talk to your table. What factors do they have in common? Why don't you go join Gracie and Jackson? Just take your notebook back there and join them for the whole time. What'd your table come up with? Table 2, what'd you talk about?
That 15 and 30 are both in the 5 multiples.
Okay, that's true. Somebody else? Did someone else's table talk about what factors they have in common? What did I say that word common means? Bye, Bobby. What did I say that word common means? The same, matching. Did we make these are factor rainbows, right? So these are our factors. What factors do they have in common or matching? What matching factors do you see here, Trenton?
15.
15.
And 3.
And 3.
5. And 1.
And 1. Are ones ever going to really do much of anything?
No, they're always not.
No, because whenever you do anything with multiplication or division, times are divided by 1. It's the same self, right? What about 15 and 30 in common multiples? The factors are the rainbow. The multiples are the list. So if I'm going to make a list of 15s, I'm going to start with
15.
Whenever I list multiples, I start with that number and I count by that number. So what am I going to start with, JC? Huh? Yeah, I'm going to start with 15. What comes after 15, everyone? 30. 45. Go ahead.
60. 75.
Good.
90.
Let's just cap it at that. That's pretty good. That's pretty good. How are we going to list multiples of 30? What are we going to do to list multiples of 30? What are we going to start with? And what are we going to count by? So I'm going to start with 30. What's 30 plus 30? Everyone? 60. What's next?
90.
And then?
120.
Let's just cap it right there.
No.
Do you see any common multiples? Common multiples. I'm up here. Hi. Common multiples. Talking to the same people all day. Gracie, common multiples. 30 and 30, good. 60 and 60, good. 90 and 90, good. That's it that we have listed.
Yeah.
What do you think would be the next common multiple?
What? Huh?
Would there be any more if we kept both of these lists going?
Yeah.
Would there be more? What would it be, Emma? It would be 120, you're right. That would also be a common multiple. Okay. So, if I'm going to show you this type of thing in a warm-up, do you think it has some important knowledge for our lesson?
Yes.
Yes. That would be an accurate thought process. Okay. I want you to look at these two sets of fractions, and I want you to think about them for a second. Both of these, I want you to think about these. In each pair of fractions, which is greater? Explain your reasoning. Explain or show your reasoning. So look at letter A. What are we going to do to figure out on letter A which one is bigger? You may write very small up at the top of your notebook. Go ahead and open to the next blank page in your notebook. Today is November 1st. Did everyone see my new cute little calendar thing? My mama got me that this weekend. She got it for me as a gift. Wasn't that so sweet of her? No, my mother, not my grandma.
It's your mother and your kid's grandma.
Yes, this is true.
Where's like the month ones though? Like I can see like the number.
Oh, I put them in a cabinet. All right. So, at the top of your notebook for today, I want you to have some thoughts for these two things, A and B. Have some thoughts. I'm going to give you like pretty short amount of time to have some thoughts. Jot down some, like 2-minute think time. Jot down some thoughts for 4/3 and 13/12. And then also for 4/3 and 7/5. Jot down some thoughts.
Write it down.
Jot down some thoughts. Yes, please. Just jotting down some thoughts. Why do you say that? Why do you say that?
4, that would make 12 by 18 times 4.
Right, and so it's not, okay, so listen, they're not equivalent. I want to know which one's bigger. Think about what you're saying. All right, let's have a conversation about this together. We're going to have two sides here. We have 13/12 and 4/3. What are we going to do to the 4/3 here? We know how to do this. We've already done it like 3 or 4 times today. We've already done it 3 or 4 times today. What are we going to do, Cameron? We're going to multiply the 3 times 4. And why did you pick 4? Out of all of the numbers in the rainbow, you chose 4. Why? Because that's going to give us a match here with the 12 here. We know we need it to be a 12. So, whatever you do to the bottom,
You must do to the top.
so 3 times 4 is 12, and 4 times 4 equals 16. What does that tell us? What does that tell us, Annabelle?
That 4/3 are bigger than 3/12.
That's right. And earlier today, I had a pretty heated discussion, a pretty heated debate with a student about drawing pictures. And so I want to show you this just because my discussion with him was pretty fruitful. If I'm going to draw 4/3, I'm going to draw it like this. So here is 3/3. That's the whole, right? And here is a 4th little third. Do you see what I did there? Now, if I'm going to draw 13/12, yeah, it's going to be very challenging on such a small space, but give me a second. Let me try again. because he was arguing with me that he wanted to draw pictures and that he could draw a picture. And I told him, see how I have 12 twelfths up here and my 13th twelfth is down here? You could draw a picture. You could relate this one to the whole and do it that way. But I'm really trying to drill home this new idea of this multiplication. And so here is what I want you to look at next. If we're going to talk about multiplication, and we have 4/3 and 7/5, what do you notice about these two things? What do you notice, Annabelle? What do you notice?
That nothing times 4 is going to equal 7, and nothing times 3 is going to equal 5.
Okay. Now, we're only working about common denominator, so that you're right about the 4 and the 7, but people in the last class also were trying to get matching numerators. And we're not working with matching numerators right now. We're just working with matching denominators. But you're right, Annabelle. 3 times nothing equals 5. And so if we look down here at number 2, Hans says he can compare 4/3 and 13/12 by writing an equivalent fraction for 4/3. That's what we did here. He's like, okay, this piece here, or what we did right here, hold on, wait, that was bad. He says, this right here, yes, I get it. Check, I'm down for that, right? He understands this. But then he's like, I can't use that same strategy for this right here. It's not going to work. Do you agree with him? Yeah. And that's what Annabelle's saying. She's like, I know I'm trying to get some kind of matching denominator, but 3 and 5 don't really have a relationship. Or do they? What did we talk about earlier? The type of relationship that 3 and 5, they were friends somehow. Huh. Those of you with your hands raised and everyone else, take whatever you're getting ready to say, put it in your pocket, and read this. Priya and Lynn. Priya? Sorry, Priya, if I'm saying her name wrong. Priya and Lynn showed different ways for comparing 4/3 and 7/5. Make sense of what they did. That is what I want you to do right now. I want you to make sense of what they did. Look at their math. Their ultimate goal is this. Oh. This is what they're trying to do right here. 4/3 and 7/5. How are they getting there? What are they doing? Make sense of what they're doing. Are they using the same strategy that we use? Huh. What are they doing? Chloe, talk to me. Make sense of what they're doing.
I seen that so when I looked at I saw that they're like both have 15 at the bottom, and then when I went down the lens, I both see that they both have 30 at the bottom. So they're both trying to get common.
Nice, Chloe. Everybody give Chloe 2 claps. Good job, Chloe. She's like, I noticed that Priya both has 15, so she's getting a common denominator of 15. And Lynn is getting a common denominator, but she's using a 30. So, are you permitted to change the name of any fraction at any time to satisfy your mathematical needs?
Yes.
And the way you do that is multiplying it by 1. Whether that's 2 halves or 3/3 or 7/7 or 10/10, whatever helps you in your life. You can change any fraction at any time. So when we have 4/3 and 7/5 like this, what Priya has done is she has taken the 4/3 over here times 5 equals 15. And over here, she has done 5 times 3 equals 15. She's like, I can get 15 on both sides. If I multiply this side by a number and that side by a number, are you allowed to do that? Yes, you are. The rule still stands. Whatever you do to the bottom, you must do to the top, because that's what gives you the number 1 right here, right? 4 times 5 is 20. Here we got to do a 3 because we need the number 1. This is the number 1, right? 7 times 3 is 21. So what's my answer? 7/5 or 4/3? Good job. Reading it like a sentence. Starting here and reading it that way like a sentence. Good work. So Priya is right. Is Lynn also right? She says 42/30, which is 7/5, is greater than 40/30, which is 4. So 7/5 is greater than 4/3. Is that what we're saying right here? Yeah. So is she also right?
Yeah.
Let's get some. Let's see. We talked about this. We talked about this. How are they alike? How are they different? Why might it be helpful to write equivalent fractions with the same denominator? Izzy?
That way it's a lot easier and you only have to compare the numerator.
Very nice. When we have the same denominator, we are free to look at the numerator. Yes, very good. Can we choose any number to be the common denominator? Why are you shaking your head no, Trenton?
Because some, like, 1, like some don't have a relationships with greater fractions.
So let's look back at this 4/3 and 7/5 since we're kind of comfortable with this problem. Let's look at this one again. What about the number 12? If I wanted to get a common denominator of 12, could I do 12? Why not? I want to do 12 though. 3 times 4 is 12. I want to do 12.
Nothing times 5 is 12.
So, I don't care.
Can't get common denominator.
The whole point of the multiplication is to get common denominators. You have to get those denominators to match up, to be common. So if I choose 12 for this side, and I choose 20 for this side, have I done anything good for myself? No, I have done.
You just made it worse.
I just made it worse. You're exactly right. I've just made it worse.
You made your problem harder.
So, can we choose any number to be the common denominator?
No.
We can't choose any number we want. We have to choose a number that has a relationship with the numbers we are given. So, if we had 2 and 4, could I choose 12? 2 times 6 equals 12. 4 times 3 equals 12? Sure, I could do that. Does it matter if we choose a smaller or a larger common multiple? So let's go back again. We're here because we're familiar. Let me erase all this wrong stuff that I did that I made it worse. Let's get rid of that. How about that? Get rid of all that. If I use a larger or a smaller denominator, does it matter whether I use, because up here I use 3 and 5, and down here I use 3 and 10, and 5 and 6. Does it matter if I use a smaller multiple?
No.
Yes. As long as you can get what you're trying to get.
As long as you can get what you're trying to get. But what's it easier to multiply something by, a 2 or a 7? 2s are easier than your 7s, right? What about 4s or 9s? What are you going to pick?
4.
Yeah. So the smaller multiple you can choose, the easier the math is going to be. So it's not necessarily going to be impossible. You just might be making life a little more difficult on yourself, right? You see what I'm saying?
Yeah.
So does it matter if we choose a smaller? Man, it doesn't really matter. But if I had my choice, I'm going for smaller. All right? Okay, I'm going to give you like 5 minutes of think time. And I want you to have some answers to these. Write these down. Are we going to use a common denominator or not? For each pair of fractions, write a pair of equivalent fractions with a common denominator. So, show me your common denominators. Go. See, more pencils on more papers. Yes, you know what you're doing. You're on it. You're thinking good thoughts. Keep thinking. Well, you're comparing 5/6 and 3/4 first. Yes. Yes. Well, you can't make them equal because they're not equal. You're trying to find out which one is bigger. Yeah, you're comparing them. No one else has used those numbers yet. Good. You're right. You're doing good. 5/6 and 3/4. Good. You're on the right track. Wait, next. You got just like that. You're doing good. You're doing great. Good. A lot of you are doing a good job. A lot of you have been listening. Good. Excellent. Good, great job, JC. Mm-hmm. All right. Now, I'm going to write some answers down on here I'm going to go through these. Same thing happened in the last class. I'm going to talk and just go through these quickly. And I want to see thumbs as I go. How are you understanding? And as your gauge kind of changes, let your gauge of your thumbs kind of change, okay? So I'm going to compare 5, 6, and 3/4. The way I'm going to do this is I'm going to make a list of 4s and a list of 6s. So 4, 8, 12, 16, 20, 24, yeah, thanks. 28, 32, I'm going to stop there. And then 6s. Hopefully there will be a match here. 6, 12, 18, 24, 30. Oh, there it is right there. So I'm going to do times 4. I'm going to do times 6 over here because it's going to give me my matching denominators that I need. Whatever I do to the bottom, I must do to the top. So times 4, that gives me a 20th. Whatever I do to the bottom, I must do to the top. That gives me 18, 20 24ths, and 18 24ths. Okay. Okay, I see your gauges changing. I see your change. Look here. Look. Look here. 6 times 4 equals 24. 4 times 6 equals 24. I now have matching denominators. Whatever I do to the bottom, I must do to the top. So on this side, I did times 4 on the bottom. So I'm going to do times 4 on the top. Times 4 on the bottom, times 4 on the top. Because 4/4 equals 1. And when I multiply a fraction times 1, I'm not making any changes to the size of the fraction. Just the fraction's name. Okay? And then over here, I did times 6. So I'm going to do times 6 to the top. That's going to give me 18 24ths or 20 24ths. Once I have my denominators the same, I'm free to look at my numerator. Right? Okay. So then I'm just going to do one more. 2/3. 5/8. 3 times 15. Whatever I do to the bottom, I must do to the top. I'm just doing it on both sides. That is the new addition to this strategy. I'm doing it on both sides. I'm doing multiplication on both sides to get a common denominator. We're going to talk more about this one more day before we start getting ready for our test, okay? All right. This concludes our math lesson for today. You guys did a great job. I love you so much. Time to load up and sanitize.